Welcome to section 2.6. This is the last section we're going to cover in chapter 2. And our goal of this section is to be able to take some data, some points that are given to us, and determine if a line is a good fit to model that set of data. So here's what happens. We look at a bunch of scattered points on a graph, and we want to find the equation of a line which is closest to all of the data. So this is one of the examples taken from part of your book, I believe. And here's what we say. In the first game, 722 people went to the football game. Okay? And the second game, 763 people went to the football game. On the third game, 772 again. And the fourth game, 826 people. Fifth game, 815, and so on and so forth. Okay, we have made this graph for you, and these are approximations. And what we have shown you is if I'm going to try and put a line in that data. Now, when you have to do this on your own, the goal is to put the line so that you have as many points above the line as you do below, or pretty close. Now, if you have a graphing calculator, look at F. If you have a graphing calculator, we are going to do this in class tomorrow because it's a little bit harder to do when I'm just explaining it to you here, and it's much easier to do when you can see a calculator as well. Okay, so I'm going to show you what happens if you don't have a graphing calculator. Now, this shouldn't be that big of a deal because we did this in section 2.4, but let me show you how it works. We're going to try and pick 2 points that are on the line. Now, if I look, I can tell you that this point at 1 is definitely on the line. My goal is to try and find another point on the line or use something that is significantly close to the line. Now, what I'm going to do is just kind of look at, I'm going to pick this one right here at 6, because that looks like it's pretty close to being on the line if it's not already. So I'm going to take the point 1, 722 and 6, 857. Okay? My goal is with these 2 points to find the equation of the line. In order to do that, I first need a slope. So I take 857 minus 722 all over 6 minus 1. Now, my denominator I know is 5. My numerator, I got to be honest, as I'm doing this, I don't have a calculator, so I'm going to do a little work here on the side a minute. 857 minus 722. 7 minus 2 is 5. 5 minus 2 is 3. 8 minus 7 is 1. So I have 135 divided by 5, which I believe 5 can go in to 135, so you're going to see a little bit more work for me on the side, okay? Now, if you don't have a calculator or you're thinking about going to pre-calc, this is some of the stuff we're going to be working on. 5 goes into 13 twice, which is 10, so I subtract 10. Drop the, take 3 is left and drop the 5. 5 goes into 35 7 times, so my answer then is 27. Now, if you have your calculator, obviously this is done for you, no big deal. Here's my slope. In order to find the equation, I'm going to pick a single point and use my slope, and I'm going through point slope again. Now, personally, because I like smaller numbers, I'm going to use the number 1, 722. So y minus 722 equals my slope of 27 times x minus 1. So y minus 722, when I distribute the 27, I get 27x minus 27. Now I add 722. Okay, so y equals, I have 27x. 722 minus 27 is plus 695. So here's my equation. Now if I use my equation in part D, predict the attendance for the 10th game, that's telling me make x 10. So if I do that, I can take 27 times 10, add it to 695, And let's see what I get. This is 270 plus 695. Excuse me. And I'm going to write that again over here. 270 plus 695. 5, 9, and 7 is 16, 8, 9. I get 965 people attending the football game. Okay? So, those of you that might be panicking a little bit because you don't yet have a graphing calculator, you are going to be fine. We are showing you that you can make this work even without a calculator. It's easier because in a few button pushes, I'm going to be able to get an equation like this just from my calculator, but it is doable. Okay, so let's slide down and we're going to talk about a little bit of vocab before we go too far into what our values are. Okay, you need to know these words, not because I'm necessarily going to ask you the straight out definition, but I am going to say use them somehow. A scatter plot is the graph of all set points. A scatter plot, if you look, looks like this. It's a bunch of points scattered around a graph. The second one, a best fitting line is the line that's closest to all of the data. To all of the data points. And I'm going to shorthand this a second. That's a T. Sorry, points. Skip it, I'll erase it. Okay. Third one. Positive correlation means, basically, let me give you an idea. That X and Y, a point X and Y are correlated. Okay, they have some sort of relationship such that as X increases, Y also increases. Okay, as X increases, Y also increases. A positive correlation basically also will mean a line would have a positive slope. So I'm just going to try and fit this in. So if I could model my data with a line, it would look like the slope of the line is positive. Okay, a negative correlation. Take a guess. Okay, XY is correlated. Such that as X increases, so as X gets bigger, Y decreases. Okay, now negative correlation, think about negative slope. As I get bigger in X, my Y values go down. So my line here would have a negative slope. Last but not least, correlation coefficient, and I'm going to give you kind of a better definition if I can, is a measure called R. Okay, it's a way we measure how strong a data is correlated to a line. Now, R can be between -1 and 1. It tells us how good a line fits the data. So, for example, if R is a positive 1, then it's a good fit. It's a line, basically. Let me erase that. It's a line with positive slope. Positive slope. I'm going to say plus slope, okay? If R is -1, then it's a line with negative slope. And if R is 0, there is no line that works. Okay, and I'm going to show you examples of all of these once we flip the page. Now, when you're ready, pause this if you need, but when you're ready, we're going to flip the page. Okay, now take a look at the pictures. We said when r is -1, it is exactly a line, and I can stick a line in here with a negative slope. When r is exactly +1, it's a line with positive slope. So let me fit this in here. If r is exactly 1, so that's this last one, all of the data points are all on the line. Then it is a line, and if it's +1, it has a positive slope. I'm going to jump down a minute. When r is exactly -1, which we looked at, the data points are also all on the line, but this line now has a negative slope. If you look at 0, look at how the points are all randomly spread around. What it means is that the points do not lie on a line. There is no line that's good for that data. Now, you have a couple of options after that. It can be kind of close to a line, like a 0.8, like a -0.8 says, okay, I can kind of stick a line in here, but they're not all exactly on the line. So when r is close to -1, the points are all close to the line, and it has a negative slope, but they may not be on the line. If the points are close to 1, like a 0.55, I don't have a positive one, but let's put one in. Let's say it looked like this, where it looks like it's all following a general path of going upward. So this is all close to a line, but again, it's got a positive slope. It's just not exactly a line until you hit 1 or -1. So here's what we're going to do. We're going to give this a shot and see if we can correlate a couple of these. Now, these are only approximations. Now, we're telling you -1, which means a negative line, +1, which means a positive line, 0, which means no line at all, -0.5, which means kind of in the negative direction, and 0.5, which means kind of in the positive direction. Okay, so our goal is, can you fit a line in? Well, if I look at the first one, it looks like it's kind of going in this direction, so I'm going to try and put a line in the middle of my data. Now, I can tell you it's positive, so whatever happens, r is going to be a positive number. Now, is it closer to 1 or closer to 0.5? In this case, if you look at my line, the data points are really close to my line, so I'm going to say r is close to a +1. Now, I would kind of estimate it truthfully as a positive, like a 0.8 or a 0.9. Your calculator is going to help you approximate these. We just want a general idea. In number 2, you can look, I can kind of put a line in here, but the problem is I have data way out here and way out here, and that's a bad thing. So in this case, I'm going to say no line exists because the data points are really far away, and I'm going to say that r is approximately 0. My third one, you kind of notice that it's following a negative trend. So I can kind of put in this line. Now this data is more spread out than the first one. So I'm going to say r is close to -0.5 because it's going in the negative direction and it's spread out a little bit more. So I'm going to say about a -0.5. Now again, we're estimating at this point in time. Our calculator is going to help us actually get exact values here. But for right now, if you don't have a calculator, you need to understand the thought of approximating as we go. So in class tomorrow, I'm going to show you how to use your graphing calculators and to do all of those equations and r values and everything like that on your calculator. But for today, I want you to get the general idea.